motion. Learning objectives for this. Key terms that you need to know, ganglion and autonomic nervous system. And these are the learning objectives, contrasting the sympathetic and parasympathetic divisions of the ANS. And then there's a whole lot of effects of each of those on these different organs. I give you some specific ones that you need to know. There, we'll talk about the James Lange theory of emotion, talk about some scenarios that illustrate its strengths and weaknesses, talk about the role of emotions in decision-making and the roles of the amygdala and prefrontal cortex. So the autonomic nervous system, you'll see here on this figure depicting the two branches of the autonomic nervous system. Ganglion, that term ganglion is shown a lot. So just want to make sure that you know what this term means. This is a cluster of neuron cell bodies, usually outside of the central nervous system. So a cluster of cell bodies in the central nervous system, in the brain or the spinal cord, is typically referred to as a nucleus. There are some exceptions. The basal ganglia are a structure in the brain that it's a cluster of neuron cell bodies, but it's not called the basal nucleus. Well, I think I have seen it that way sometimes, but typically referred to as the basal ganglia. So you can see that the sympathetic nervous system, it's got ganglia. There are axons coming from the spinal cord, synapsing onto new neurons in these ganglia, these clusters, and then they send their axons to these effector organs all throughout the body. The parasympathetic nervous system has axons that extend from the spinal cord, and they're longer, and then they synapse onto ganglia that are near the effector organs. So there's new clusters of neurons there, new ones in terms of, down the chain that they'll talk to, and then they'll send short axons to the effector organs. So the sympathetic nervous system. This is often referred to as the fight or flight system. This is useful in emergencies. You'll see an increase in sweating. The reason why I wanted you to know about sweating is that this is a common experimental measure that you'll see in the literature, a measure of skin conductance. So basically you could have some electrodes that are these flat, sticky electrodes, just kind of like stickers that you can put on your hand. And sometimes they look different, and they will measure the degree to which they're able to conduct electricity. If your hand is covered in salty water, i.e. sweat, then skin conductance is going to go higher. So this is also used in polygraph tests and lie detector tests, and then in which there's whether those work or not, that's a topic for another time, but they're used also widely in psychology research to get a measure of sympathetic activity, because your palms are going to sweat when your sympathetic nervous system is activated. Decreasing digestion and increasing heart rate. Parasympathetic is nicknamed the rest and digest system, or also feed and breed. So you're going to have increased digestion. That the parasympathetic division is going to trigger also decreased heart rate and increased sexual arousal. If you're in an emergency, then you're going to be more concerned with just getting out of that threatening situation rather than digesting your food, putting energy towards that, or reproduction. Both of them involve involuntary activities. These are things that you can't really exercise conscious control over. And that's also evident in that they control smooth and cardiac muscle. These are, as opposed to skeletal muscle, which we have voluntary control over, moving our bones around, but we can't really control how fast our digestive tract moves
food through it, or at least not directly control our heart rate. And we don't have to think about it either, which is great. So the James Lange theory of emotion, you may remember this from general psychology. William James is a prominent figure in psychology, of course, William James, and then Carl Lange is the other side of the other part of this name. It's kind of a counterintuitive theory that states that you have some event, some trigger in the environment, and then there has to be some kind of an appraisal, some kind of an interpretation of what that stimulus is and what it means. And then there is an action that you take. Maybe it's running, maybe it's jumping, maybe it's moving the muscles in your face to adjust your facial expressions. And there's also specific physiological activities that occur. That's the heart rate increase, sweating, and etc. And then the emotional feeling, the subjective experience of emotion, comes after that. So the chronology of this is critical, that all of that happens, and then you have this subjective experience of emotion, the feeling that I'm feeling afraid, or I'm feeling happy, or I'm feeling angry, or whatever. Okay? So here are some scenarios that provide some evidence for or against the James Lange theory. So pure autonomic failure, panic attack, exercise, facial manipulations, and Mobius syndrome. So pure autonomic failure, that's where your autonomic system is not working. Okay, and people who have this disorder, they can still experience emotion. However, it is less intense. So this provides some evidence kind of both ways, right? James Lange was right to some extent that emotions are less intense if you don't have that autonomic response, but there is still the subjective experience of emotion in the absence of any of that physiological response. So kind of some evidence for or against there. And that's kind of the current understanding. The James Lange theory does provide some useful insight, but it's not the whole picture. And there are situations in which it really falls apart. Panic attack. This is where autonomic responses with some unknown cause, it's not really known what has triggered them, that's interpreted as an emotion. So your autonomic nervous system goes into overdrive somehow, and then you interpret that as feeling panic. So this is some pretty solid evidence for the James Lange theory that you're entering this specific physiological state, and then that subsequently leads you to interpret that as an emotion. Exercise. When you exercise, you're going to have a high level of physiological arousal. Your heart's going to be beating. You're going to be sweating. However, you don't interpret that as, oh, I'm running now, so I must be afraid. So this really provides some strong evidence against the James Lange theory, suggesting that it doesn't hold up in this situation. Facial manipulations, like if you force a smile or if you force a frown, that is going to enhance that specific emotion to some extent. So that provides some evidence for the James Lange theory as well. It's still mild, but there's the facial feedback hypothesis. You may remember that from general psychology. There's some evidence to suggest that you can influence your emotions just through your facial expressions. Here's an interesting disorder called Mobius syndrome, where individuals are born with facial paralysis, so they're unable to smile in response to feeling happy. However, these individuals still experience happiness. So this is more evidence against the James Lange theory that even though they can't smile, they're still able to experience happiness. And sometimes surgery can correct this, where muscles are taken from some other part of the body to allow them to smile, because there is a social detriment to not being able to smile, where you can't show that you're laughing at someone's joke, for example. but it doesn't mean that suddenly they feel happiness after that surgery, but it just helps with the social aspect. Okay, so the role of emotions in decision making. Maybe you have heard of this trolley problem. I'll let you review it in your textbook. But basically it's, is it ethically acceptable to, if you're standing on a bridge and a trolley is careening out of control towards 5 people who can't move out of the way, is it morally permissible to push this heavy-set individual off this bridge onto the tracks, killing him but saving the 5? So it seems logical. You save 5 lives at the expense of 1, but many people have some qualms with this. And it's believed that we don't like this idea of pushing him off the bridge and causing his death because we're anticipating how that outcome will feel. Interestingly, people who have a higher autonomic response, probably measured through skin conductance, or other similar measures, are less likely to make that logical choice to push the fat man off the bridge. This is another example of a way in which emotions influence our decisions. This is the Iowa gambling task that shows kind of how it works. You've got these 4 decks of cards. Some of the cards look like they're so you kind of just draw cards from these decks and you can get money at the end of the task. Usually you kind of start out with a fixed a certain amount, and then you can lose or gain some, and they're good decks and bad decks. The bad ones have these large penalties, even though they seem to be, even though they have larger gains, they have such big penalties that they're really bad. And if you are choosing those decks, then you'll learn quickly, like, oh, this is not where I want to be. However, people with lesions to the ventral medial prefrontal cortex do not perform very well at this task. They don't earn as much money. They tend to not avoid those high loss decks. And they also have impaired emotional expression. So this has been shown to be an important area for calculating the value of an outcome, what an outcome is going to feel like, and the emotion, expression of emotion. And just as an FYI, you don't need to know this anatomically, but you should be able to deduce from the name where this should be. So this is a mid-sagittal section showing where the ventromedial prefrontal cortex is, the VMPFC. The amygdala, we've learned about the amygdala a little bit, at least you've identified it anatomically. When we built the brains with Plato, the 2 hippocampi and the temporal lobes are kind of each holding an amygdala. They come down like 2 arms. So this is a deep temporal lobe structure, something you have to slice into the brain to see. The amygdala regulates anxiety, regulates the startle reflex. So the amygdala appears to be very important for emotional learning, things like fear conditioning. So associating a particular stimulus with an emotional response. Rodents with amygdala damage will still startle in response to like a loud noise or some threatening stimulus. However, they don't learn to associate it with cues. So they won't be able to learn the association between some previously neutral stimulus and that threatening stimulus, and so they don't startle in response to the previously neutral one. And startle reflex isn't only measured in rodents. I mean, you can watch a rat jump and measure that, but it's also done in humans. So this is what that might look like. Electromyography measures muscle contraction, and you could put some electrodes on somebody's eye, and when they blink, when they startle, you're able to measure that. If somebody has damage to the amygdala, you'll see things like this, just fearlessness, trouble identifying fearful expressions,
a big part of identifying fearful expressions is looking at somebody's eyes and how wide they're open. And if there's damage to the amygdala, there's no automatic tendency to orient your attention to the eyes. If the amygdala is working normally and you put somebody in an MRI scanner, you'll see a good way to get it to light up is to show fear-evoking stimuli, emotionally charged images, things like graphic depictions of violence, guns pointed at you, mutilation, things like that. This is just kind of some story time, but maybe a fun illustration to kind of drive this home. This is a picture of Alex Honnold. If you didn't recognize him from his face, maybe you'd recognize him from this picture. So this is him climbing El Capitan in Yosemite National Park. And you notice here that there are no ropes above or below him. He's a free solo climber. So he's well known for climbing these crazy cliffs without any ropes or harnesses. And he would be classified as a sensation seeker, somebody who seeks out a lot of emotional stimulation. I can post this link in the YouTube description to this video. This is him showing, you can watch him climbing a great big cliff in Zion National Park as well, called Moonlight Buttress. Even just looking at this picture and watching this video makes my palms sweat a little bit. They're a little sweaty right now. This is a picture of a normal person's brain in an MRI scanner when they are looking at emotionally evocative images, things like violence and mutilation, things like that. This is Alex Honnold's brain, and here you can see there's some activity here in the amygdala that is noticeably absent in Alex Honnold's brain. So he definitely seems to process emotional stimuli differently than us. This study was actually done where I did my PhD. Dr. Jane Joseph, who studies sensation seeking, works in the office just down the hall from my shared office with all the grad students. So she does some really cool research. Anyway, there's a link here that you can look up in the slides to see an article about him.